Wiener. Alright, man, it's rolling. Also, could you move to your left a bit so I can see the projections? Okay. Oh, I meant, sure, that works. So, like, I'm teaching about, like, cell respiratory or something. Oh, sorry to stop you, dude, but I think the slide says, cell respiration. Yeah, that's what I said. So, like, in cell respiratory, there are, like, 5 stages, I think. It says 4 stages where I'm looking. There are 4 stages of cell respiratory, and, like, the first stage is, I think it says glycolysis. I was getting there, dillhole. Let me talk. So, like, I don't know. Do I need to know this for, like, the quiz or something? I don't know, man. You're the professor. You decide that stuff. Oh, whoa. Really? Sweet. So, like, none of this is required, then. Hell yeah. Well, no, I think you still have to make the video for the board assessment or whatever. Aw, man, this is bull.
Hi, I'm Matthew Baldridge, and welcome to episode 1 of Meeting the Criterion. Glycolysis is the first step in cellular respiration, and it occurs in the cytoplasm. It splits one 6-carbon glucose molecule into 2 3-carbon pyruvate molecules. It is an anaerobic process that requires an initial investment of 2 ATP molecules and produces a total of 4 for a net gain of 2. It also produces NADH, an important electron carrier that we will get back to in a later episode. Thanks for watching.
Dude, don't do that again. You almost broke my baby. Just, like, get a new one, or something. Get a new one? Do you know how much these things cost? Oh, whatever, you're not gonna understand anyway. So I think you need to talk about, or mention, or do whatever with how you teach about the Krebs cycle now. Oh, well, like, crabs are cool. Yeah. They're also, like, tasty. Yeah. No, crab, not crab. I don't know anything about vegetables. Alright, this isn't getting anywhere.
Hi there, episode 2. Before we get on to the Krebs cycle, we have to mention the link reaction. The rest of cellular respiration will take place within the mitochondria. This starts with the pyruvate being entered into the mitochondrial matrix and being decarboxylated, meaning its CO2 will be removed. This forms a 2-carbon acetyl group. Next, reduced from NAD+, NADH is created while the pyruvate is oxidized. This all happens twice per pyruvate. After this, the 2-carbon acetyl group attaches to coenzyme A. In summary, pyruvate from glycolysis and NADH form with 2 CO2 as waste, 2 NADH, and 2 acetyl coenzyme A out. Now we can talk about the Krebs cycle. So, that acetyl group that I just mentioned adds to a 4-carbon oxyl acetate in order to make 6-carbon citric acid, with the coenzyme A being sent back. Next is the decarboxylation, where 2 CO2 are removed one at a time. After this, more oxidation happens and NAD plus and FAD reduce to NADH and FADH2. And finally, more ATP is also formed from substrate-level phosphorylation. The entire process is also completed twice per pyruvate. And to grossly summarize again, acetyl coenzyme A, 3 NAD plus 1 FAD, and 1 ADP form coenzyme A, 3 NADH, 1 FADH2, 1 ATP, and 2 CO2. See ya!
Alright, I wrote up a note card with information I totally did not word for word copy off a textbook for you to read about the electron transport chain. All you have to do is read off it while I film. So like, I have to read this? Yeah, that's what I just said. What if, like, I can't read? Or something. You can't read? Of course you can't read. What's that supposed to mean? You think I'm stupid or something, dillweed? Quite honestly, yeah. I thought you were just a profound teacher with like a new form of teaching when I met you. But no, you're kind of just dumb. Well, why don't you take this for dumb? Well, I'd say that's very dumb. And where do you keep finding these chairs? Oh, I don't know. Think fast. Oh yeah, I can play that game too. Ow, man. What the fuck?
Alright. I'm just gonna explain the electron transport chains, since they are getting nowhere. Alright, so the NADH and FADH2 from before drop off the electron they've been carrying onto the electron transport chain. This is the NADH and FADH2 being oxidized. The electrons move along the chain, which makes active proton pumps move hydrogen ions from oxidation out of the matrix of the mitochondria, which makes them go into the intermembrane space of the mitochondria. These pumps create a proton gradient, which results in protons moving through ATP synthase by facilitated diffusion, and this gives the energy to phosphorylate ADP to make into ATP. Then, at the end of the ETC, the electrons are taken by the final electron acceptor, which grabs the 4 electrons along with 1 oxygen and 4 hydrogen ions to produce 2 water molecules. This is the reduction of oxygen. Alright, we're done? Any questions? Nah, I'm just kidding. I can't hear you. Bye!
So like, some things I forgot or like that weren't clarified. So like the net or overall reaction of cell respiration is like carbon 6, hydrogen 12, oxygen 6 plus 6 O2 makes 6 CO2 and 6 H2O molecules. Also, the purpose of cell respiration is to make ATP. It makes like 36 to 38 in total. ATP has energy, and then ATP is like what the cell uses for energy, because it can't afford a generator. It needs that ATP. Make sure to like read the pictures that I drew. There's like a few things that are in the rubric that Matthew didn't say. That's my bad for not making it clear enough in the script. But a few things are explained in the pictures that aren't necessarily explained in the epic explanation. Like citric acid is like the first intermediate. I mean, that's like, that's obvious. It's basically said. And then it was, I'm pretty sure it was said NAD plus and FAD are reduced to gain electrons and hydrogens during Krebs cycle to form NADH and FADH2. Yeah, the CO2 that's a waste product is breathed out because, like, duh. Oh yeah, for the electron transport chain, like on the picture, there's the inner membrane, then the like inner membrane space, where all those hydrogen ions go, and then there's the matrix, which is like that movie from the 90s where the stuff comes from, where the NAD, the electrons come from, and then like push their stuff into those pumps. I think there was one more thing. Yeah, okay, during the... Wait, no, that was said. Okay. Yeah, no, I think I got everything. If I didn't, it's in the pictures. It's very, very likely in the pictures. So, I don't know if I need to say it. Like, I need to say what was going on. But it's in the picture, so at least it's in the video. I'm going to sleep now. Please help me.
Discord. Okay, perfect.